So our next video is really the nitty-gritty of simplifying radicals, right? We're just using all those different things we've learned about radicals and parts of a radicals, and, prime factorization. We're using those skills and those vocabulary to simplify these complex radicals. So we have a list of steps that are going to help us along the way. And we're not going to tape this in yet. Eventually we're going to tape it in here so that we have the directions on the front, and then we have a piece of tape and we can fold it like this, kind of like a book. Fold it over and look at the examples that go with the steps. For now, since you're going to be referring to the steps, simply put them to the left of your page, so as we go through each problem, you can refer to the step that we're on. So the first one we're doing asks you to simplify the cube root of 27x to the fifth y cubed. Now, if you look at your steps, the first one says write the prime factorization of your radicand. Right? So we have to write the prime factorization of this. In order to do that, we need to know the prime factorization of 27. So I'm going to use my birthday cake method, or a factor tree if you want, to find the prime factorization of 27. So a prime number that goes into 27 is 3. 27 divided by 3 is 9. And again, 3 works. And again. And I get my candle. So the prime factorization of 27 is 3. So when I write this out, okay, I'm going to write out this prime factorization here. I'm going to have the cube root symbol, right, my index, and then the radical symbol here. But this whole prime factorization, this is 3 times 3 times 3, right, which I found from there. And x times x times x, 5 times. 1, 2, 3, 4, 5. And y times y times y. So that is the prime factorization of 27x to the fifth y cubed. I'm expanding it all out, right, with each factor. And there's a purpose to this, I promise you. Okay. Number 2 in our steps says determine the index of the radical. Well, this one, the index is 3. Right? I'm going to go ahead and circle 3. That's my index. Okay. Now, that tells me what groups, or like how many of each group I'm going to pull out of this radical. Okay. So I'm going to start pulling out groups of 3. Okay, so 3, 3, and 3. There's a group of 3. Okay, x, x, x. There's a group of 3. Right, no more x's, but y, y, y. There's a group of 3. Okay, now 3 times 3 times 3. Right, well, if cube root is finding how many times you would multiply a number, or what number you would multiply 3 times to get, well, 3 cubed is 27, which means the cube root of 27 is 3. So that's why pulling these out works. I'm looking for groups of 3 to pull to the outside of the radical. So I pulled out a 3. I'm pulling out an x. I'm pulling out a y. Okay. Now, what do I have left inside of the radical symbol? Well, I still have the cube root of x times x. Okay. And this would be, can I write my final answer, 3 x y, And then what I have left over is the cube root of, and I'm going to rewrite this as x squared. Okay, so there's my final answer. And I'm circling that in a third color, which is orange. I know it's hard to see the difference between red and orange. Okay, so what I've done is I've pulled out perfect cubes. 27 is a perfect cube. It's 3, right? X cubed is a perfect cube. So I pulled out an x. Y cubed, right? Y cubed is a perfect cube. So I pulled out a y. Okay? And x squared is not a perfect cube because it would have to, be greater than 3 for me to pull it out. So there's no more x's left to combine with x squared, so I had to leave it inside this cube root symbol. Okay? And that's how you simplify cube roots. And so we'll keep going with example 2. For example 2, we're finding the fourth root of 64 x to the 8th y squared. So again, my first step says to write the prime factorization of that radicand. So I need to know the prime factorization of 64. So I'm going to use the birthday cake method. Again, you're free to use whatever method you want, but I have a feeling this one's going to be pretty lengthy, so I'm going to start down here. Prime number that goes into 64, it is even, so I know 2 goes in, and it goes in 32 times. Another even number gives me 16. Another even number gives me 8. And again, and again, and one last time. So 64 is 2 times 2 times 2 times 2 times 2 times 2. Okay, so a lot to that one. But now I'm going to write the prime factorization of my radicand. So I'm going to do that in red. So I've got the fourth root of, and this one's going to be long, 64 was 2 times 2 times 2 times 2 times 2 and times 2. Right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. X to the 8th, well, that's x being multiplied 8 times. 1, 2, 3, 4, 5, 6, 7, and 8. And then I had y squared. Look at that, I didn't even, I thought it was long enough and it wasn't. There we go. So that's my prime factorization of that radicand. And now I'm going to start circling groups of 4 this time. Right? My index is 4, so I'm going to circle groups of 4. So there are 4 2's. I've got 4 x's. I've got 4 more x's. And that's really all that I can take out. So I can take out a 2. I can take out an x, and I can take out another x. Now I'm left with fourth root of, I've got 2 times 2 times y times y. Okay. Now I want to simplify this even further. Let me show you how we can do that. 2 times x, well, these are the same base. X times x is really x squared. So this becomes 2x squared. Okay, don't confuse these. Right? This is 2, and then x times x is x squared. And then we have the fourth root of 2 times 2 is 4. And y times y is y squared. And there's our final answer. I'll circle it in orange to show that it's final answer. There's nothing else that we can do. I can't pull out a fourth root from 4, and I can't pull out a fourth root from 2. So that's as simple as we can get. And our final example is the fifth root of 32, x to the fifth, y to the fifth. So again, my first step is to write out the prime factorization of that radicand, and I need to know the prime factorization of 32, which I kind of already have. If I look up here, okay, pretend that there's no 64 here, well, that is the prime factorization of 32. It's just 2 times 2 times 2 times 2 times 2. So do I really have to do it out again? Not really, right? I have it right there. So let's use it, right? Why do more work? So as I write the prime factorization out, I have the fifth root of, let's see if I can estimate correctly how long that's going to be. 32 is, we did it right here, 2 times 2 times 2 times 2 times 2. So that's 5 of them. Right, 1, 2, 3, 4, and 5. X to the fifth, that's x being multiplied by itself 5 times. And y as well to the fifth is y being multiplied by itself 5 times. So that's pretty perfect. Okay, and then my next step is I figure out what my index is. In this case it's 5. So I'm going to be pulling out groups of 5. And I've got 5 2s. So I'm pulling out a 2. 5 x's. So I'm pulling out an x. And 5 y's. So I'd be pulling out a 5. Right, so 2 x and y, and there's nothing left, right? That's it. So my final answer is just going to be 2 x y, and I can circle that one in orange. If there's nothing left, there's no point in writing the fifth root symbol, right? Because there's nothing inside of it. You wouldn't be taking the fifth root of anything. So the answer here is just 2xy. And if I wanted to check my answer, right, since I know that taking the fifth root of something and, taking the fifth root of something is really just the opposite of raising something to the fifth power, right? So what I would do here is, if you remember back from our exponent rules, I would distribute this 5 in, 2 to the fifth, and then x to the fifth, and y to the fifth. And this is really 32, x to the fifth, y to the fifth, which is what's in here, right? So fifth root and raising something to the fifth power are opposites. So if you ever want to check your answer, you can do it that way. Now that we have all 3 of those examples, you're going to take your steps and put a piece of tape on here, creating a page within a page. And so you can flip it over and have your examples right there of simplifying radicals with your steps. And these are the problems that you're going to complete on your own. Okay. On the left side, you're going to find the cube root of 8c to the third, and then the cube root of 56b squared. Number 3 is the fourth root of 176g to the seventh, w to the fifth. And the last one, number 4, is the fifth root of 224z to the seventh.